Good day. So in this video, we're going to enrich our discussion on integration. So previously, ang kino-consider lang nating interpretation for the integral is it's the general antiderivative of a function. Na ganun yung case kapag indefinite integral yung sinosolve natin. It will give us the general antiderivative of a function. But if we're going to consider what we call the definite integral, ang interpretation na niya ngayon would be the area under a curve. So let us first be introduced to the two main goals of calculus. And ito yung solving these two problems. First is the tangent line problem. Second is the area under a curve. Now in tangent line problem, if you would recall derivatives, this would be the slope of the tangent line. So everything you have learned from your differential calculus course, it pertains to finding the solution to the tangent line problem. Now for area under a curve, ito naman yung integral. So ito yung i-discuss natin for integral calculus. Now these two problems, ang pinaka-fundamental concept nila ay yung concept ng limits. So, ibig sabihin, in the long run, ito yung mga, ang integral calculus sa differential calculus, they are still linked to the concept of limits. So, let us discuss the area under a curve. So, for instance, ganito yung ating curve. So, this one is the function y equals x from 0 to 4. Na kapag ganyan lang, technically the curve forms a triangle with respect to the x and y axes. So, we know the formula for the area of a triangle, which is half of the product of the base and the height. So we can simply get the area under this curve by measuring the base and the height. Yung base niya, this is 4, and its height is also 4. So yung area natin would be 1/2 of 4 times 4, which is 16 over 2 or 8. Now kung ganyan lang ka-simple yung area na hinahanap natin, of course, we can use known formulas for such. However, that is not, most of the time, that is not the case. So, for example, ganito yung area na gusto nating hanapin. Of course, this is not a known shape. Wala naman tayong formula na maa-apply para ma-generate or makuha agad yung area under this curve. So, ang gagawin natin, we will actually estimate the area under a curve. We will estimate the area using shapes that we know the formula for the area. So, in this case, ang gagamitin natin ay rectangular shapes. So, ang wari, this one. If we have this rectangle, we can get its area. However, this is obviously an underestimation of the area of the actual curve. So, what if ang gamitin nating rectangular region ay ito? So, it's again a rectangle. We can simply get the product of the two lengths, the base and the height, or the length and the width, to get the area. But, of course, for this particular curve, this is an overestimation of the area. Now, let us consider more rectangular regions. So let's say 2. This one and this one. So while it may not still be a perfect estimation or a um perfect shapes to use for this particular curve, medyo mas nami-minimize na natin yung layo niya from the actual region. So let us continue by considering more rectangles. So let us use 4. Apat naman. So 1, 2, 3, 4. So we have 4 rectangular regions right now. But as you can see, dito kulang, dito sobra, dito medyo okay na, pero dito kulang pa rin. Now, we can continue doing this process over and over again. So the more rectangles we use, the better approximation we will be getting. So that's actually the idea of how we will estimate this. So now we're using rectangular regions kasi madaling makuha ang area ng isang rectangle. No? Area of a rectangle is simply length times width. Or pwede natin isipin na itong measure na to times this measure. Pero ano ba tong measure na to? Since this is a function of x, this height here is simply f of x. So, depende na lang siya sa x value na to. As I've said, the two main problems of calculus are linked to the concept of limits. Kasi ang gagawin natin is we're going to generate an infinite number of rectangular strips. Well, it's not really an infinite number, but a very large number of rectangular strips until such a time na each rectangular strip when combined, or all rectangular strips when combined, will actually fit the curve very well. Okay? So in symbols, the definite integral as area under a curve would be written this way. So if f is a function defined on the closed interval ab, the definite integral of f from a to b is given by this one. The integral from a to b of f of x dx is equal to the limit as n approaches infinity of this sum, I from 1 to n of f of x sub I times delta x. Now, this part here, this sum here, actually takes the sum of all rectangular regions that we have considered. Okay? This is technically the function value. Ito yung parang height ng rectangles na ginagamit natin. And delta x, this gives us how far or how wide the rectangles are. Now, we're considering the limit as n approaches infinity. So, ano ibig sabihin nito? Ibig sabihin, nag-generate tayo ng sobrang daming rectangles. until such a time na yung delta x natin becomes very, very small. Or we can think of it as the change in x, so how wide the rectangular strips are is actually very, very small. So delta x will become 0 or yung rectangular strips natin will actually become very thin hanggang ang itsura na niya ay parehas na parehas sa curve. So ito na yung concept ng limit sa integral calculus. Okay, so kailangan lang that this limit exists. And if this limit exists, then we say that f is integrable, this is on the closed interval AB. Okay, so balikan lang natin yung earlier example natin, no? And i-apply natin yung definite integral limit definition. So again, this is y equals x from 0 to 4. So, the definite integral from 0 to 4 ng x dx, this is actually the limit as n approaches infinity ng sum from 1 to n ng f of xi delta x. Okay. So we have to find the x sub I and delta x. Delta x, this is how far or how wide the rectangles are. Ibig sabihin, itong entire interval na to divided by the number of rectangles. So that would give us 4 minus 0 over n or 4 over n. Okay? Now, if we want to generate the x sub i's, mag-start muna tayo. Hanapin natin yung pattern. So, x sub 1, this would mean from the initial value ng x, so that is 0, tapos magdagdag tayo ng delta x plus 4 over n. So, this is 4 over n. Yung x sub 2 natin, this is x sub 1 plus delta x. Or 4 over n plus 4 over n, which is 8 over n. Okay, x sub 3, this is x sub 2 plus delta x. Which is 8 over n plus 4 over n or 12 over n. So, hopefully, nakikita na natin yung pattern. So, x sub I would actually be 4 over n times I. Okay, let's just erase these scratch. Now we have delta x and x sub I. So we can now write this as the limit as n approaches infinity ng sum from 1 to n. Ang f of x sub I ay 4 over n I. Then yung delta x natin ay 4 over n. Okay, now if we're working with this sum, technically kailangan lang natin i-consider yung index or yung tumatakbong variable. Ang tumatakbong variable lang naman dito ay I. So, the other terms, we can actually take out of the summation sign or ilalabas natin siya. This is the limit as n approaches infinity. Ilalabas natin tong 4 over n na to. Saka ito pang isang 4 over n. So, in turn, magkakaroon tayo ng 16 over n squared. Ang summation ay from 1 to n ng I. This part here, hopefully, still looks familiar. This gives you the sum of the first n natural numbers. Tama? And if you would recall, this is n times n plus 1 over 2. So we have the limit as n approaches infinity ng 16 over n squared times n plus 1 over 2. Now, this is a limit at infinity. So, this is n squared plus n. As you can see, same yung highest power, both numerator and denominator. So, matatanggal yung dalawang yan. Okay? And this part here would actually be 0. So, ang lalabas na lang sa limit natin ay 16 over 2, which is still equal to 8. So, different method, but same yung result. Okay, so we can end this video here. In the next video, we'll consider more examples of the definite integralist area under a curve using the limit definition.